Alright guys, today's going to be a first impressions video of the Uni-T UT210e, I believe. So anyway, this is a little clamp meter that I decided to buy after having quite a bit of frustration trying to track down a parasitic load on a vehicle with my current clamp meter that I have, which it only reads down to 0.1 amps, and it really doesn't do that reliably at all. You almost have to be pulling about 5 amps through whatever circuit in order to be able to trust the meter that I have now. It's an Elenco ST3030 is the meter that I have now. I'll probably break that meter out eventually in this video and show it to you. But anyway, this is actually true RMS. It measures DC current through the clamp as well as AC current through the clamp, and it's only 30 bucks, so quite cheap. Not sure, well, obviously it's not going to be meant for like probing real high power stuff, but the nice thing with this is that the DC amps, it actually goes all the way down to 1 milliamp in terms of resolution. So there we go. Comes with a little carrying case, not the best quality thing that I've really seen. It's got some frayed sort of string coming out of it, frayed thread I suppose it is. So let's open this up. Just a little case, I'll get you by. So there is the meter itself, pretty small. Now let's see, where's the piece of tape? There we go. Slide this out. Clamp takes a little bit of force to open. Nice and smooth actually. Doesn't really open terribly far. It's about the width of my finger there. I think it's 17 millimeters is the quoted jaw opening length. I'll take this off too, I suppose. I don't know if it comes with batteries or not. Apparently the answer to that is or not. It's 30 bucks, what can I expect? What do we got here? This is June 2017. I have no idea what that actually says. I guess it's date of manufacture. Yeah, I don't really know what that is. It doesn't seem like a calibration. I guess just some kind of certificate for something. And then this would be the operator's manual, and then yeah, so we've got the presumably it's English, it might have Spanish on it too, and then there's the Chinese operating manual, so throw that away. And then the leads are in this part of the case here. I've got the little Cat 4 things on them. What do the leads say that they're rated for? Uni-T branded. It says Cat 4 600 volt and Cat 3000 volt. So the leads are actually rated at least to be quite high. Of course this thing pulls off. Actually a little bit sharp. It's not bad. We'll see. Can't get this back on. There we go. I do kind of like having these cap things. I mean, they're meant to be probing around real high voltage stuff so you don't accidentally short stuff out, but I like these for getting in the weird spaces that well, there's a whole bunch of wires sticking out. You know, it's quite useful for that, even if it is on low voltages. I'll take that out. It's got the little sort of protection plugs in the banana jacks there. Alright, so the wires in the probes aren't too bad. They're kind of stiff. They're not the worst that I've felt, but not the best either. They seem reasonably thick as well, though I doubt that these are rated for current at all, because this meter does not measure current whatsoever through these two jacks. It's only the clamp. And actually, never mind, the probes are rated for current. 10 amps on them. I guess it's just cheaper to make one set of probes, isn't it, for all their multimeters? So that makes sense. Then these probes will just plug in the bottom. That is kind of annoying. That it would have been nice if the probe stuck out straight, but yeah, it's not bad. They're just gonna have to kind of lay off to the side like that. And again, there's no battery, so I can't mess with this thing. I'm gonna have to go and track down, I think, a couple of AAAs probably for this thing. But anyway, we'll do some first impressions testing on this. All right, well, I couldn't find any real AAA batteries, so we're just gonna have to hope that these rechargeable ones will give enough voltage and that they're actually charged. So anyway, we'll go ahead and stick those in it and hopefully it actually works. Now this is not going to have a fuse in it more than likely. Actually, I've seen teardowns of this before. It does not have a fuse in it, and the reason why is because there's no current measurement ranges that actually go through the meter. It's only with the clamp, so there's not really any point of having a fuse in it. So hopefully those will have something. And low battery warning, of course. So I might just throw those on the charger for a while and see if I can get the voltage up. But anyway, that's volts AC. You can see even the screen says true RMS on it. It's kind of weird. At least the true RMS goes out when you start measuring DC, so that's good. But anyhow, I'm going to throw those on the charger and we're going to take a bit of a closer look at this meter while those hopefully come up to voltage a little bit. Of course, I don't tend to use rechargeable batteries all that often. So they kind of sit around and then they die because self-discharge. Well, these are older Energizer ones. This is before like the real low self-discharge technology became a big thing. But anyway, I'm going to throw these on the charger and we're going to take a closer look at the meter. Fun fact, those batteries are actually at about 1.25 volts already. So that low battery warning is actually coming on quite early for what you'd kind of expect it to be. Usually you'd expect like 1 volt per cell as a low battery warning, but we'll see, I guess. Anyhow, so true RMS is 2000 counts. Apparently the maximum current that you can push through this clamp is 100 amps. And let's see about the CAT ratings on here. It's CAT 3 300 volts, CAT 2 600 volts, so that's not actually that bad. Not too bad for rating. You wouldn't go poking this into like 480 volt, you know, real high energy stuff, but it's good enough to probe stuff that's plugged into the wall with no real worries. So it'd be great if this wasn't like tangled around my tripod, but all right, so what else do we have on the front of the meter here? So down there, that's basically just telling you what the jacks are used for. That's and then this one's the common jack, and there's a warning symbol there. Anyway, so this is a select/VFC button. I think VFC has to do with like the variable frequency drive motors. Not entirely sure, I haven't read the manual. 0 button and a hold / button to turn on the backlight. So the range switch goes from off to volts AC / volts DC. We have ohms, capacitance, continuity, and diode check in that range. And all these are auto ranging ranges, I guess. And then going up into the current measurement, they are actually manual ranges. So you have 2 amps, 20 amps, 100 amps, and the very top thing is non-contact voltage. And this little bump up here, I believe, is the sensor for the non-contact voltage measurement. And well, I can't really do a whole lot else with this thing. Now there is a little LED right there. It's got a CE mark on it. All right, so on the back of this thing, we've got this barcode. We've got some screws that you could use to take it apart. Have the battery cover, which I don't remember if I mentioned this or not, but it does actually have a metal threaded insert on that. So that's good. We've got an ETL mark on it. We have warning that tells you to remove the test leads before opening the case. And then there's a little QR code type thing. So anyway, not too bad. All right, so the range switch on this thing doesn't feel too bad. It's got good solid detents between everything. It's not the greatest feeling thing ever, and it will, like if you just barely touch it like that, it will get stuck between 2 ranges. Probably not the biggest deal though, because it's hard to do unless you're trying to do that. At least that's my first impression on it. Have to use it for a while to figure that out, but you know, the rubber buttons, they feel like rubber buttons. And yeah, it feels pretty decent in the hand. Fairly small meter. So anyway, I guess I gotta wait for batteries to charge up somewhat and stick them back in here, and hopefully we can do some testing on those. I don't know, it's probably not recommended to use rechargeable batteries in this thing. It probably actually says somewhere, possibly inside the battery compartment, that is like use alkalines, but we're gonna try it with the rechargeables and see what happens. And if the readings are way off, I'll find some real batteries and stick them in there. Though it shouldn't actually matter whether it's rechargeables or alkalines, as long as that low battery light's not on it, we should be okay. Alright, so I've been using the little UT210e for a little while now, and I'm going to tell you my thoughts on it as it sits now. Still not really a full review, but first off, one little thing that I don't really like is when you turn it on, either the voltage range or the current ranges, it's always in AC volts, which it's just kind of an annoyance to me. If you work more on AC stuff than DC stuff, it wouldn't be too big of a deal. But the other thing is, if you try to measure a DC voltage, for example, this battery pack I have over here, when it's in AC volt mode, watch what the meter does. It just kind of freaks out and displays overrange and beeps at you because it is overranging. Now, that's kind of a disadvantage to this meter, if you ask me, because sometimes you actually do want to measure AC volts when you put the probes across a DC source. For example, if you're trying to measure the ripple on a power supply, that could actually be quite useful to be able to do that, though this thing doesn't seem to have that capability. So basically, for me anyway, every time I turn this thing on, I have to change it into DC volts by hitting that select button. Alright, so we'll go ahead and measure across our battery pack now that we're in DC volts. And there we go, 10.42. Auto ranging is reasonably fast. It's not bad anyway. So anyway, one other little complaint. If you turn the backlight on, backlight's bright enough and everything else, and it actually works pretty well if you're looking at it in a dimly lit room, but you'll be going along here measuring stuff, and you'll notice that backlight really doesn't stay on for very long. See, it just shut off. So that's nowhere, it's not even close to a minute probably that it's on. So that is kind of annoying. It has the backlight, but it's almost useless because it doesn't stay on for long enough. So anyway, next we'll just show the auto range speed on resistance going all the way down to 0. Again, not too bad. The other modes in here, the diode check mode actually does seem to work okay for like reasonable voltages, up to about 2 volts. I've used it on a diode drop and it worked just fine. But before we get to the diode drop, we'll go continuity. Most certainly fast enough to do most things. One thing that I do notice is that the probes that it comes with, especially when they were brand new, you could almost lay them on top of each other and they wouldn't make a connection. Now they seem to be getting a little bit better. I don't know if they had like some oil on them or something like that that had to be scratched off with a little bit of use, but some different probes might be a good investment for this meter. And one other thing to note, I actually plugged in the probes from my Bryman multimeter into this meter, and the continuity buzzer on this thing with good probes is just as fast, if not just a little bit faster, than the continuity meter or the continuity buzzer on that BM235. So that is kind of interesting to note. So continuity is certainly fast enough for just about anything that you're going to use it for, especially if you get better probes than these. And these, I am kind of thinking about getting some different probes. I remember hearing about some that aren't too expensive that are actually made in the US. I just can't remember the manufacturer of them. That I'm going to have to find those things again and see if I can't get a set for this meter. Anyhow, moving on. Next range, diode drop. Alright, so now in the diode check mode, we've got a red LED. We'll just measure across it. Should be able to measure that. It actually lights it up. 1.657 volts. So yeah, the diode check mode, I'm sure that you're probably going to be limited by the 2 AA's that are in this thing. I could go ahead and get a white LED and try it. Alright, so I went ahead and found a white LED. We'll go ahead and measure across this, see if it's got enough voltage there to light one of these up. It actually does light it. Doesn't look like it's going to measure anything, but it does light it up. There you go. So yeah, it's not going to actually measure that, though it does light it, which is interesting. This may have a maximum, because of the 2000 counts, it may actually have a maximum of about 2 volts. So interesting to note that it'll light a white LED, but unfortunately it doesn't measure it. So that was actually the first time I tried that, by the way. Should look at the manual. It probably tells you it only goes up to 2.5 volts, something like that, and that white LED is probably closer to 3. Alright, next is capacitance mode. I don't know, I should have a capacitor around here somewhere. I don't think I've actually tried the capacitance mode on this either. It's not something that I really use all that often. But I've got these 2 capacitors, which were actually used in a different video for capacitor testing. I'm not sure which one of these is the bad one, which one is the good one. But we do have a bad cap here and a good cap. And we can zero it out, though it's not like it's floating real high. And you can wipe the zero out by holding the button down. And then I'll go back to the standard measurements. So we'll put this across here. Rating 63 nanofarads, so that capacitor is the bad one. Let's see if I can get around here without blocking all the whole reading. And this might take a while to actually read. They tend to. 195 microfarads. That wasn't too long to read that, so I classify that as a pass. And the next thing, and the most important thing to me with this meter, was the current range. Again, always going into AC first. And one thing that I kind of find annoying about that is if you're in one range here, since this is actually manual ranging, for some reason the current ranges are all manual. I mean, all the voltage stuff is automatic, but the current range is manual. So anyway, one annoying thing about that is if you have it set to DC and you realize that you need more current or less or whatever, and you change ranges, it actually goes into AC again because of that manual range, and everything defaults to AC. And you see it actually tells you it's true RMS on the screen, which is kind of funny, I thought. But anyway, what I've been kind of surprised at is how well this thing actually measures DC currents. So if I pull this wire into shot here, zero it out, hopefully there's some current going through here still. Yep, 1.2 amps flowing through that wire. And it actually, you can move it around a little bit, and it does. It's going to change a little bit, as these Hall effect sensors tend to. But it's not too bad. It's not nearly as bad as my old Elenco ST3030. That thing would vary by, 8 amps just by moving around like this. This one's varying by 20 milliamps. Or so let's zero it out again and see. 5. See, it's not bad at all, really. Not nearly as bad as what I thought the cheap little $30 meter would be anyway. So this actually works really well, if you ask me. I've tested up to about 20 amps with it. I haven't gone to the full 100 amps. We can probably pull a little bit more current through this wire. And again, it's going to default to AC. So there we go, 1.18. We'll see if we can't just draw a little bit more current out of this. Here's 2 amps, 5 amps, 8 amps, 0 amps because something tripped in the current limit. And then going up, I do want to bring one more thing up. We have this non-contact voltage thing, and if I bring it up to a voltage source, let's see, I should have a cord here. If I bring this cord in, and there's that little sensor right there toward the front. If I bring that in, it actually has a nice little bar graph on it too, which is kind of cool. One thing that I noticed is that it actually has that little red LED up there. And the only thing it uses that LED for is the non-contact voltage. Now I think, personally, that it would have been cool if they could have had the little red LED light up when you were using continuity mode. It just would have been something that would have been a little bit nicer. Then you have two indications, one with the beep and then one with that red LED, which would be useful for you know, sort of noisy environments and stuff like that. And it definitely does seem like they just kind of have it rigged in with the so it's just on with the beeper. Especially when you notice that when it turns off and it beeps to let you know that you've changed ranges, the light actually blinks when you come off a non-contact voltage. So yeah, I'm just thinking it would be a pretty neat thing if they could have had that red LED light up with the continuity mode as well, though that's just a little minor thing. So anyway, as for the accuracy, I've compared this a little bit against the Bryman meter, and it actually seems to be spot on with it in terms of both the current range and the voltage range. So I was quite impressed with this little thing, considering it's only 30 bucks. I haven't really tested the I haven't tested if this thing's true RMS or not. Let's go ahead and bring in something that would probably confuse a non-true RMS meter. So I just have a power inverter, which is one of the cheap modified sine wave types. Should read something like 115 volts. Let's just see what it does if I shove the probes into the socket. 126 volts, which is probably reasonable because it's a really cheap inverter and it doesn't have any kind of load on it. So that actually appears to work just fine. I would be curious. Let's plug something into it and see if it, because the other cheap meters that I've hooked up to these inverters, they will swing from like 90 volts all the way up to 130 depending. Yeah, it's still 126 volts, so yeah, the output of this inverter might be a bit high, but it does appear that this meter is capable of measuring true RMS. So that's good. Alright, and just as one more little demonstration here on that AC, the sort of AC only mode that it won't let you measure across DC. This supply over here should have a decent amount of AC ripple on it. And you see, you just get that same overload error and it just kind of goes crazy. So that is kind of unfortunate that you can't do that. So that's probably my biggest current annoyance with this meter, besides the fact that the backlight just doesn't stay on for anywhere near long enough. The auto power off thing is kind of annoying too. I guess I've just gotten used to the Bryman where the auto power off time is like half an hour and it will reset like every time you actually measure something that's different. So this thing will shut off after I think about 15 minutes. Though you can disable the auto power off on this thing. I figured out if you hold down select and you turn it on, beeps 3 times, you notice there's no longer that little clock symbol up in the corner of that LCD that there normally is. So there's no symbol there, and if I turn it back on, that symbol's back on again. So it is possible to disable auto power off on that meter. But anyway, overall, I'm quite impressed with this little thing. It's only 30 bucks, and I'm mostly interested in this meter just for the current clamp. That's the only thing I really care about on this. Though I've been using it on the bench here a lot, and I'm actually quite happy with this thing, measuring DC volts and whatnot, and resistance and everything else. I've been using this quite heavily in the last couple weeks, and I'm really happy with this meter actually, especially considering the price. The only thing that I don't really like about the hardware here is the probes are kind of questionable. They almost seem like they have some kind of corrosion or something on the tips that is keeping it from making a really good contact when you're doing continuity and you just kind of smack the tips together. Though it doesn't seem to make too much of a difference when you're actually measuring stuff. I'm going to go out here and say that this thing is actually quite a nice meter, especially, well, mostly if you need some kind of a current clamp. And I've actually become quite used to using this just to measure anything around here, because it does measure that really, well, relatively low current stuff quite accurately. Just a little while ago, I was using this thing to measure down about 20 milliamps just to see if something was on, not necessarily to measure that for any kind of accuracy. I just wanted to see if something was on, and it worked just fine for that. So anyhow, I quite like this thing. It's coming in handy already, just for measuring little stuff around the bench, messing with this battery management system board here and trying to hack it into doing balance charging. But anyway, that's a different video. So anyway, I like this little meter, and that's about it for now, guys. Bye.